Okay, welcome to the second discussion video. This is section 1.2 on exponents and radicals. I've had a few questions asked I'm running two classes, so I've had a few questions asked for both of those classes. So let's take a look at these problems. We'll start with number 8. Number 8 says to evaluate each expression, right? So we want to come down to a number, just some final solution. The first one is 3 to the third times 3 to the negative 1. With this 3 to the negative 1, I can rewrite that as 1 over 3 to the 1. And in order to multiply these two things, I can think of it as 3 to the third over 1 multiplied by 1 over 3 to the 1. I can multiply these here, or I can simplify. It doesn't really matter how you look at this. I'm going to get 3 to the third over 3 to the 1. One of the exponents will cancel, so this leaves me with 3 squared. And 3 squared is, of course, 9. So your answer should be 9 for the first part. There's two more parts here. The other ones, second one says 6 to the 7th over 6 to the 5th. I'll just work that here to the side. 6 to the 7th over 6 to the 5th. Using the subtractive law of the exponents, 6 to the 2. In the end, evaluate, which means operate everything that you can, and so the squared turns us into 36. And I should get that. And then the last one says 3 over 3 to the negative 2. Let me just go ahead and erase this so it doesn't get too messy. 3 over 3 to the negative 2. But this 3 to the negative 2 can come upstairs, so this ends up being 3 times 3 squared. But that's just 3 to the third, and 3 to the third is 3 times 3 times 3. That's 27. And that's 8. That's number 8. Next one we wanted to look at, the next one that was asked was number 9. And it says evaluate as well. It says negative 2 over 3 that is raised to the negative third power. So first off, I have a negative inside. I have this negative here. I can take care of that negative by maybe flipping this, right? The very first thing I want to do is maybe call this negative 3 over 2 to the third power. Is one thing that I can do, because that negative is just going to flip everything. Now I have a negative that's being raised to the third power. That's going to be a negative times a negative times a negative. It's still going to stay negative in the end. So it will still be negative. I have 3 to the third in the numerator, as that gets distributed in, and 2 to the third in the denominator. And then, of course, it said evaluate, so evaluate these. 3 to the third is 27. 2 to the third is 8, right? It's not 6, it's 2 times 2, which is 4 times another 2, which gives you 8. And the negative, of course, stays, and so I end up with negative 27 over 8. And that's 9. Number 15 was asked. So 15 says evaluate again, and I'm given the square root of 15 multiplied by the square root of 60. So if I have two radicals being multiplied, square root of something times the square root of something else, I can call that the single square root of those things multiplied together. But rather than trying to multiply these together and getting some big ugly number I don't care about, 900, I'm going to start breaking it apart from here. Because even if I got my big number, I would then figure out what the square root of that is by breaking it apart. And so I can say that 15 is 3 times 5. Those are primes, so I'm going to circle them. 60 I can say is 6 times 10. Those can break down more. 6 is 2 times 3. 10 is 2 times 5. And under a radical I need pairs to pull out. So I have a 2 that can pull out with a 2. 3 can pull out with a 3 because there's a pair of them, and a 5 that pulls out. There's nothing left inside the radical, so I don't need to write it. I end up with just 2 times 3 times 5 is 30. That's not to say that you can't multiply these together. It's just easier if you're going to break it down this way to just already have it broken in one piece. If you didn't, you said, well, I want to multiply these together, you get 900, right? And you might be able to know that 30 is the square root of 900. This one's not terribly difficult, but if you didn't, you would start breaking it down anyway. And you could start with 15 times 60, which is why we would just break it down here. So that's 15. Or excuse me, 14, that was 14. 14. All right, 17. Seventeen says, evaluate the expression, and we're given the square root of 12, and added to that the square root of 27. I can't add radicals together unless they're the same radical, right? And these are not the same right now, but 12 is 3 times 4, and 4 is 2 times 2. I have a pair of 2's here that I can pull out, so this becomes 2. The 3 has to stay under the square root. And then 27 happens to be 3 times 3 times 3. We've seen that. So I can pull out a pair of 3's, but I have to leave a 3 behind. And now my radicals are the same, right? 2 root 3's plus 3 root 3's, altogether, this is 5 root 3's. Once these guys are the same radical, then I can combine them using the reverse distribution process, and then combines to 5 root 3. Let's take a look at 18. It's similar to this, but uglier. Eighteen says we have the 5th root of 5 minus the 5th root of 160. Now the 5th root of 5 I can't do anything with. This the index of 5 means I need 5 factors to be able to pull out of the radical, but I only have one factor of 5, so I can't do anything with it. With this 160, I can say is 16 times 10. 16 is 4 times 4, if you will, and each of those 4's gives me a 2 and a 2. And then this 10 gives me a 2 and a 5. I'm under a 5th index, so I need 5 to pull out, but I have 1, 2, 3, 4, 5 2's. So since I couldn't change this guy, I'll rewrite it 5th root of 5 minus, but I have 2, I have 5 2's to pull out, so I have a 2 out here, and a 5th root of what's left is that 5. My radicals are the same, they're both in terms of 5th root of 5, and so I have one of them minus 2 of them, that's minus 1 of them, so it's just the negative 5th root of 5. The next one we want to look at is 20. There's a few expressions here. The ones that were asked of me were the bottom 2, so let's take a look at those. I have y to the 5th over y to the 8th. Call this b. Y to the 5th over y to the 8th. And that all gets taken to the negative third. Okay? So I want to simplify this down just to y to some power. I can start by, inside the parentheses, taking fifth and eighth. It's like a subtractive. I can take 5 minus 8. So this becomes y to the negative 3 inside, raised to the negative 3, right? Or I could call this 1 over y to the third. It doesn't matter. Because when I take this power and that power together, they multiply, and this is going to give me y to the 9th. So your answer here, they're looking just for the power. It says this is equal to y to the b, where b equals what? Well, b is the power, and it's just 9. Well, let's look at the third expression in this one. Call it C maybe. This one is 6z to the third squared. It gets multiplied by 2z to the negative 5, which is to the negative 2. Okay. And this is equal to I see. And so they have this equal to, they have an input box for the number in front, and then z to the c, and then it says where c is equal to what? So there's two inputs. There's the number in front of the expression, and then c gets input down there. So let's start with these powers, right? There's not a whole lot I can do inside these parentheses unless I wanted to take that z to the negative 5 and put it in the denominator. I'm not going to, because I'm going to mess with the negative in a minute anyway. And if you're messing with the negative in a minute, you may as well just chuck that in there and then pick up the pieces afterwards. So I'm going to take this 2 in, but recall that everything in here gets squared, including that 6. So 6 gets squared, that's 36. Z to the third squared, that's z to the 6, because those multiply, right? And then the same thing happens here. I get 2 to the negative 2, right? So I get 1 over 2 squared, if I want to chuck it downstairs. And I get z to the negative 5 times negative 2 is positive 10. Right? 1 over 2 squared, I'm just going to erase this here and call that a 4 in the denominator. And then 36 divided by 4 is 9. Z to the 6 times z to the 10 gives me z to the 16. And so I have it, my answer should look like this. The number in front was a 9, the c is 16, there we have it. All right, let's take a look at number 24. Says, simplify the expression, and then we're given x y squared z to the third. And that is all raised to the third. And x to the third y z to the fourth. All to the third. Hopefully I wrote that right. It's very small. X y squared z to the third in the numerator. All to the third. And then x to the third, y z to the fourth, all to the third. Okay, and this is supposed to be then x to the a, y to the b, and z to the c. And they ask you a, b, c. For your inputs. There we go. So I would start with distributing the 3 through the numerators and the 3 through the denominators. This becomes x to the third. Y to the 2 times 3 becomes y to the 6. Z to the 3 times 3 is Z to the 9. And then the denominator, I get x to the 9. Y to the 3. And Z to the 12. 4 times 3. And then I just simplify, right? Looking at my x's, there's more x's in the denominator than the numerator, so I'm going to take 9 minus 3 is 6 and put it in the denominator. That is x to the 6 in the denominator. With my y's, there's more of them in the numerator, so I'll take 6 minus 3 is 3, and so I have y to the 3 in my numerator. And then with my z's, I have 12 in the denominator, 9 in the numerator. The difference between that is 3 in the denominator. Right? But that's not how they wanted it. They wanted x to the a, y to the b, z to the c. They want it all in one line. So this x to the 6 and the z to the 3rd, I want up there. So that is x to the negative 6 when that pops up. Y is already there, so it's y to the 3rd, and then z pops up as z to the negative 3rd. And those are your answers. A is negative 6, B is 3, and C is negative 3. Good. And then I had multiple people ask me to do the last 3, so 27, 28, and 29. Let's look at those. (27) says, rationalize the denominator. And we have 1 over the square root of 3. So to rationalize with something just including a radical, all I have to do is multiply by that radical. So I multiply both the top and the bottom by that square root of 3. The top then becomes irrational, but that's okay. We don't care about the top. We want to rationalize the denominator. I have root 3 times root 3. That is 3. And I'm done. Right? The denominator is a rational number. There's no square root. That's it. It's that. (28) says just do the same thing. 28 says rationalize the denominator, and I have a square root of a fraction, 2/5. Right? But this 2/5, let me make sure that's what it is, yeah, can be rewritten as the square root of 2 divided by the square root of 5, and I don't really care what's going on in the numerator. All I care is that this denominator gets rationalized. So I multiply the top and the bottom by the square root of 5. Specifically because my denominator, the square root of 5 times the square root of 5 is 5. Up top I have the square root of 2 times the square root of 5. I can just multiply those together inside one radical, and I end up with the square root of 10 over 5. And that's it. I'm done. And then 29 is similar, but of course ever so slightly different. Rationalize the denominator and simplify where possible. But we're given this 4 over the square root of 2x. Now, just because they've got something a little bit hairier under here doesn't change anything. I need to multiply the top and the bottom by the square root of whatever's hanging out here, right? And so I multiply both the top and the bottom by the square root of 2x. Because now the square root of 2x times the square root of 2x, there's 2 factors of 2, 2 factors of x, so that's 2x. In the top, I simply have 4 times the square root of 2x. And normally, the last 2 questions we said, oh, we're done, this is good enough. But this one, there was one set of additional instructions, and that said, simplify. which you should always do, you just couldn't do it on the other two. But I can here because 4 and 2 can divide. There's a 4 in the numerator, is divisible by the 2 in the denominator. So simplify those, they're both divisible by 2, that leaves me with the 2 upstairs. So that leaves me with 2 times the square root of 2x all over x. And that, you'll see, is an answer down there in those options. All right. Hopefully this was helpful for you. If you have any other questions, feel free to email me. We can talk about them. But I will see you guys on the next one.